Organic farming, manures and green manuring. Organic farming is not a new concept. Actually, from the first day of agriculture in human civilization, it is based on organic inputs. But with the development of chemical fertilizers, pesticides, fungicides, herbicides, there is a transformation of farming or cultivation from organic based to chemical based. The age of this transformation is only about 100 years. In the present day, intensive farming system, chemical inputs are largely used throughout the world, which cause depletion of soil fertility and degradation of environment. In the context, organic farming is gaining importance not only in our country but also in the world. When we discuss organic farming, manure is an important input. The word manure was originated from the French word manure, meaning work with soil. Manures are substances which are organic in nature, capable of supplying plant nutrients in available form, bulky in nature, having low analytical value with no definite composition, and most of them are obtained from animal and plant waste products. So you can easily understand that there is a clear division between manure and fertilizer. Fertilizer is made in factories where there is definite nutrient content in fertilizers. Classification of manures. Broadly, manure can be classified into two groups: bulky organic manure and concentrated organic manure. Bulky organic manure is further divided into three groups. First, farmyard manure or FOM. There are different types like cattle manure, sheep and goat manure, poultry manure, etc. Second subgroup under bulky organic manure is compost. There are usually two types of compost which are commonly known as rural compost and urban or city compost. Now there is a third type of compost which is becoming popular day by day, that is vermicompost. Third subgroup is sewage and sludge. When I discuss on concentrated organic manure, it has two subgroups. First, oil cake. There are two types of oil cakes. One is edible oil cake and another is non-edible oil cake. Second subgroup, waste products of slaughterhouse. There are different types like blood meal, bone meal, fish meal, horn and hoof meal, etc. Besides bulky and concentrated organic manures, there is another group that is known as green manuring. It can be classified into two groups based on their practices. First, green manuring in situ. It can be done by two types of plants. One is leguminous plants and the second one, that is the non-leguminous plants. Another type of green manuring is green leaf manuring. Bulky organic manure. The most common type is farmyard manure, which is known as FYM. The term farmyard manure has been coined to designate the manure produced in the farm itself. It is the oldest and most commonly used bulky organic manure. The basic constituents of FYM are dung, that is solid excreta of farm animals, urine, litter, that is bedding material like dry leaves, cereal straw, other kinds of vegetable matter, etc. Factors affecting the composition of FYM. The important factors which cause variation in composition of FYM are: number one, the kind of animals and their age. For example, young or growing and milch cattle retain more nutrients than old or sick animals. Number two, the nature of fodder given to animals. For example, bajra straw and maize straw usually have greater nutrients than wheat and paddy straw. Number three, the composition of litter. Number four, the method of preparation. It is very much important. Preparation of FYM. FYM is prepared in pits of 6 to 7 meter long, 2 meter wide and 1 meter deep under shade. Every morning, cattle dung mixed with urine soaked litter is sprayed in a section of 1 meter length from one end of the manure pit. When the section is filled up to a height of 45 to 60 centimeter above ground, it is plastered with cow dung soil slurry. The whole manure pit is filled up section wise. The mixture of cattle dung and urine soaked litter being 60% moist is decomposed by microorganisms. The decomposition increases the temperature to 50 to 60 degrees centigrade. The mixture of cattle dung and urine soaked litter is usually composed of non-nitrogenous like cellulose, hemicellulose, lignin, starch, sugar, etc., and nitrogenous like protein, urea, uric acid, ammonium salts, etc. The carbon compounds are usually converted to carbon dioxide and water, while water soluble nitrogenous compounds undergoes decomposition due to microbial action, which is converted into ammonium salts. Fats are first converted to organic acid and then after decomposition it is converted to carbon dioxide and water. In this way, the volume of mixture is gradually reduced. The original yellowish brown color darkens and ultimately becomes black. FOM is ready for application within 3 months. As the nutrient content in FOM is very low, therefore FOM can be reinforced by application of superphosphate at the rate of 20 to 40 kg per trench before application to land. Use of farmyard manure. FOM is a traditional organic manure which is readily available to the farmers. It is generally applied in soil by broadcasting method during land preparation, but it should be sprayed evenly and mixed with the soil immediately after application. The average nutrient content of FOM is 0.5% nitrogen, 0.3% P2O5 and 0.4% K2O. The method of application of FYM generally adopted in our country is defective. Most of the farmers keep FYM in small piles at different places of the field for a month or so before incorporation. The exposure of FYM to the sun and rain leads to a considerable loss of nutrients. Generally, 30% nitrogen, 60 to 70% P2O5 and 70 to 75% K2O become available to the first crop, and rest of nutrients become available to subsequent crop as residual effect. The rate of application of FYM varies with crops, climate and cultivation systems. The crops that show profitable responses to application of FYM are rice, sugarcane, jute, potato, etc. While leguminous crops, jowar, bajra, barley, cotton, etc. are less responsive to FYM. Compost. All nations, especially the underdeveloped ones, face a problem of disposal of waste organic materials in rural as well as urban areas. Such organic materials may be converted into a dark brown or black colored decomposed material. So, compost is the well decomposed product of rural and urban waste materials. Compost is usually of two types. Number one, rural compost, and number two, urban compost. In recent times, another type of compost known as vermicompost has become popular in the country. According to the latest available estimates, in the year of 2010-11, given by Jadhav 2011, 102.3 million tons of compost was produced in India, and that was applied to 18.6 million hectare land, that is 13% of net cropped area in the country. Out of total compost produced in India, rural compost accounts for 78%, while urban and vermicompost 11% each. Among states, Karnataka is the largest producer of both rural and urban compost, while Kerala alone produces almost half of the total vermicompost in the country. Rural compost. This type of compost is prepared from village waste products like straw, crop stubbles, residues, weeds, litter from cow shed, etc. The average nutrient content in rural compost is 0.4 to 0.8% nitrogen, 0.3 to 0.6% P2O5 and 0.7 to 1.0% K2O. Rural compost is largely used for cultivation of crops in rural areas for a long time. Indoor method for preparation of rural compost. The method was devised by Howard and Ward at Indian Institute of Plant Industry, Indore. The process is aerobic. It is carried out in trenches of 30 feet, that is 9 meter long, 14 feet, 4 meter wide and 2 feet, 0.6 meter depth. Each trench is divided into 6 sections of 1.5 meter each. The farm wastes are sprayed on the trenches and cow dung is added on each layer. When the trenches are filled to a height of 1 feet above ground level, the top of the heap is made dome shaped and plastered with cow dung mixed earth. The turning of heap is done at 2 weeks, 4 weeks and 8 weeks for well decomposition. The compost is ready in 3 months, which contains about 1% nitrogen, 0.5% P2O5 and 3% K2O. Super compost is a type of rural compost which is prepared by country method. It is carried out in trenches arranged in rows measuring 15 feet long, 5 feet wide and 3 feet deep. The pit is made concrete under a shed. The whole length of trench is divided into 3 equal parts. First, a layer of refuse of 1 foot thick is spread at the bottom of first part of the trench, and 7 kg single superphosphate, that is SSP, is added over it. In this way, another 7 kg and 6 kg SSP are added over second and third layer refuse respectively. When the trench is filled to a height of 1.6 to 2.0 feet above ground, the top of heap is made dome shaped and plastered. In this method, after first part of the trench, third part of the trench is filled up in the same manner. Thereafter, the middle part or the second part of the trench is filled up. A total of 60 kg SSP is required for whole trench. The manure is ready within 4 to 5 months, and 3 tons of compost can be obtained from a trench. This type of compost is called super compost, which contains about 1% nitrogen, 1% P2O5 and 1% K2O. Urban compost or city compost. These type of compost in municipal towns, cities, that means in urban areas. It is prepared from town waste materials, including market wastes, street sweepings and night soil. The nutrient content of city compost is about 1.2 to 2.0% nitrogen, 1.0% P2O5 and 1.5% K2O. The urban compost is usually prepared by the Bangalore process. The method was developed by C.N. Acharya at Indian Institute of Science, Bangalore. The composting is carried out in trenches arranged in rows having 5 feet vacant space between them. The trenches are made at a site at least 1 kilometer away from the town. The size of the trench varies with the population and quantity of refuse. When the population is below 10,000, the size of the trench is recommended as 20 feet length, 6 feet breadth and 3.5 feet depth. Population 10,000 to 20,000. The length of the trench is about 20 feet, breadth or width 7 feet and depth 4 feet. Population 20,000 to 30,000. Length 30 feet, breadth 8 feet, depth 4 feet. Population 30,000 to 50,000. Length 35 feet, breadth 8 feet, depth 4 feet. Population above 50,000. Length 40 feet, breadth 8 feet, depth 4 feet. Although these are the recommendations for the size of trenches for preparation of urban compost following Bangalore method, but the size of trenches may be modified depending on the size of waste materials available and the area provided for preparation of urban compost. After collection of city refuse that is spread to a thickness of 9 to 10 inches within the trench, which is covered with a layer of night soil about 3 inches thick. So, the ratio of city refuse and night soil is usually 1:3. When the trenches are filled up to 1 feet above ground level, they are plastered with mud. The compost is ready within 5 months. The advantages of this method include it effectively controls foul smell. Number 2, it does not need turning, which reduces labor charges. Number 3, it reduces the loss of moisture and nitrogen because the composting is done in trenches. The manure is suitable for vegetable cultivation in urban areas, but some of the farmers do not want to use the manure due to their prejudice because night soils are used in this method. Here it may be noted that in some cities or towns, night soil is now not used for preparation of urban compost for this reason. Vermicompost. Beside rural and urban compost, there is another type of compost known as vermicompost. This compost is prepared by the action of earthworms. It is gaining popularity among the cultivators day by day due to its nutrient content and other beneficial effects. Vermis is a Latin word meaning earthworm. There are some definitions which are related to vermicompost. Vermiculture. It means scientific method of feeding and raising earthworms in controlled condition. Vermicomposting. It is a method of making compost with the use of earthworms. Vermitechnology. It is the combination of vermiculture and vermicomposting. Earthworm species. Earthworms play an important role in soil ecology. Out of 300 earthworm species in India, only a few are imported in relation to the production of vermicompost. More specifically, 3 earthworms are commonly used for vermicomposting. These are Icenia fotida. It is an exotic type which is popularly known as red worm or tiger worm or manure worm. The second important species is Eudilus eugenie. It is also an exotic type which is known as night crawler. Third type is Indigenous type, which is Perionyx excavatus. The biomass production of exotic earthworms like Eudilus eugenie and Icenia fotida may increase to 40 to 90 folds within 3 to 6 months with adequate space and food. Vermicompost is prepared in pits, concrete tanks, plastic or wooden tanks, well rings, etc. with provision of drainage. Preparation of vermicompost. Vermicomposting is a bio-oxidation process of organic materials and involves the joint action of earthworms and microorganisms. It consists of 3 steps. Number 1, preparation of partially decomposed organic material. Number 2, preparation of vermibed and inoculation of earthworms. And number 3, harvesting of vermicompost. Green or dry organic biomass, mostly agricultural wastes like straw, crop residues, banana pseudostem, water hyacinth, etc., mixed with fresh cattle dung are covered with polythene sheet under shade. Partial decomposition takes place with the action of microbes. Here it should be noted that when the biomass undergoes decomposition, it increases temperature to 40 to 50 degrees centigrade. In addition, fresh cattle dung during decomposition generates heat and produces ammonia along with increased temperature. But the earthworms cannot function well beyond 35 degrees centigrade. For this reason, partially decomposition of organic waste materials is carried out outside the vermi production unit without involvement of earthworms. This partially decomposition requires about 30 to 35 days. Before placing this partially decomposed material to the vermi beds, vermicomposting unit should be made, for which a shady upland having no chance of water stagnation is selected. The selected land is leveled with a gentle slope to one side for providing drainage. Within the vermicomposting unit, vermi beds of 10 feet long into 3 feet wide and 1.5 feet deep are made, and partially decomposed material is placed and earthworms are released. The beds are covered with straw and the straw should be kept moist by frequent sprinkling of water during the production of vermicompost. The vermi beds must be protected from red ants because red ants are harmful for earthworms. The brownish black vermicasts are found within the vermi bed and they are ready for harvesting within 30 to 40 days depending on the season. Use of vermicompost. The average nutrient content of vermicompost is 1% nitrogen, 0.8% P2O5 and 0.8% K2O. The nutrient content may also vary with the type of organic waste materials used for vermicomposting. For example, when the crop residues or stovers of leguminous crops like mung bean, cowpea, black gram, etc. are used for vermicompost. In such cases, the nutrient content of vermicompost is usually higher. Vermicompost is mainly used as basal before sowing or transplanting and rarely as top dressing to standing crops. The average rate of application of vermicompost is 100 gram vermicompost for a pot containing 8 to 10 kg soil, while 1 to 10 kg vermicompost per tree depending on size and age. In case of field crops, the recommended dose of vermicompost is about 2 to 5 tons per hectare. Vermicompost is granular in nature. Its application increases aeration and water holding capacity of soil. You may know that vermicompost is now a popular manure used by the farmers. Therefore, the rural cooperatives, agro-based companies have started the production of vermicompost commercially and they sell vermicompost even with packets. So So we can easily understand. Although rural compost is commonly available to the farmers for its application in the field, but the farmers are now ready to purchase vermicompost for getting higher production for their high value crops. Concentrated organic manure. Concentrated organic manures are those that are organic in nature and contain higher percentage of major plant nutrients compared to bulky organic manures. It is usually of two types. One is oil cakes and another type, that is the products of slaughterhouse. First, oil cakes. The residue left after extraction of oil from oil seeds is known as oil cake. It is estimated that at least 2 million tons of oil cakes are produced in India about every year. Although a large variety of oil cakes are produced in the country, but they are usually classified into two major groups. Number one, edible oil cakes. These are commonly fed to farm animals and therefore they are used very much less as manure than the second one. Example: mustard cake, groundnut cake, sesame cake, etc. Number two, non-edible oil cakes. These are exclusively used as concentrated organic manures. Example: neem cake, koranja cake, muwa cake, castor cake, etc. Nutrient content in oil cakes. We have already discussed that there are two types of oil cakes. One is edible oil cake, another is non-edible oil cake. Among edible oil cakes, mustard cake contains about 5.1% nitrogen, 1.8% P2O5 and 1.2% K2O, while groundnut contains a little more nitrogen, that is 7.1%, 1.5% P2O5 and 1.3% K2O. The nutrient content in sesame cake is about 6.2% nitrogen, 2% P2O5 and 1.2% K2O. Among non-edible oil cakes, neem cake, which is known to the farmers It contains about 5.1% nitrogen, 1% P2O5 and 1.4% K2O. Koronja cake, its nutrient content is 3.9% nitrogen, 1% P2O5 and 1.3% K2O. Mohua cake, the nutrient content is comparatively less, 2.5% nitrogen, 1.8% P2O5 and 1.8% K2O. Castor cake contains 5.6% nitrogen, 1.8% P2O5 and 1% K2O. Country honey oil cakes usually contain a little more oil than hydraulic or expeller pressed oil cakes. So, the first type, that is country honey oil cake, is somewhat slow acting, as oil prevents rapid conversion of nitrogen into available form. The carbon nitrogen ratio in oil cakes varies as 3 to 15:1. So, organic nitrogen is quickly mineralized, generally to be available to crops within 7 to 12 days. But Mohua oil cake contains less nitrogen and it nitrifies very slowly, that is about 2 months, because it contains a toxic substance called saponin. So, Mohua cake is recommended to apply at least 2 months before sowing, preferably in moist soil. Use of oil cakes. Oil cakes need to be well powdered before application. For uniform and easy application in the field, as well as quick decomposition in soil by microorganisms. Oil cakes are applied a few days before sowing or transplanting, preferably in moist soil and wet weather, than dry soil and dry weather. Oil cakes are recommended for high value or commercial crops on economic grounds. So, oil cakes are not generally used in cultivation of cereal crops, pulses and oil seeds in our country. In our state, the farmers who grow Govindabhog rice in South Bengal, they sometimes use mustard oil cakes for top dressing in the field. Besides the use of oil cakes as nutrient source, there are also some reports that oil cakes, particularly the neem cake and mustard cake and koranja cake, may have some insecticidal properties. So, if they are applied in the field as external organic inputs, but the pest infestation may be less in such fields. Groundnut and coconut cake are applied for top dressing of sugarcane. Farmers growing betel leaves sometimes use oil cakes. Other concentrated organic manures. Besides oil cakes, there are other concentrated organic manures used in agricultural fields, such as blood meal, meat meal, fish meal, horn and hoof meal, bone meal, etc. In short, it may be mentioned that these particular concentrated organic manures are the products of slaughterhouse or different markets. The nutrient content of such meals vary, which may be described as blood meal contains 10 to 12% nitrogen, 1 to 2% P2O5 and 1% K2O. The nutrient content of meat meal is 10% nitrogen, 2.5% P2O5 and 0.5% K2O. Fish meal contains 4 to 10% nitrogen, 3 to 9% P2O5 and 0.3 to 1.5% K2O. Horn and hoof meal contains high amount of nitrogen, that is 13%, but without any phosphate and potash content. Bone meal contains 3 to 4% nitrogen, 20 to 25% P2O5, but with very negligible or no potash content. These type of other concentrated organic manures are quick acting in nature and they are usually effective for all crops and all types of soil. Green manuring. The practice of ploughing or turning of undecomposed green plant materials into the soil for the purpose of improving physical condition and fertility is termed as green manuring. And the manure obtained by this method is known as green manure. Desirable characteristics of green manure crop. Number 1, it must grow quickly to produce abundant green foliage. Number 2, it should require less nutrients and water for its own development. Number 3, it should preferably be a leguminous plant having the capacity to fix atmospheric nitrogen in soil. Number 4, it may have deep tap root system. It must be kept in mind that green manuring is not a new technology. It is an age-old technology which has been farmers at their own levels for a long period. Now, in the context of chemical based intensive farming system, the green manuring is getting priority to restore the fertility of the soil as well as for sustainable cultivation. There are two types of green manure crops. Number 1, leguminous, and number 2, non-leguminous. Leguminous plants can fix atmospheric nitrogen through stem or root nodules having the nitrogen fixing bacteria. In addition, they also provide organic matter to the soil. The common examples of leguminous green manure crops are Dhoincha, that is Sesbania aculeata or Sesbania rostrata, Sanin, Crotalaria jansia, green gram, Phaseolus or Vigna radiata, cowpea, Vigna sinensis, etc. The non-leguminous green manuring plants provide only organic matter to the soil and their use is limited. The examples are mustard, Brassica species, maize, Gia maize, etc. Methods of green manuring. There are two methods. The commonly used method is green manuring in situ. Green manure crops are grown in situ or in field and then they are buried before flowering in the same field before sowing or transplanting of the next field crop. For growing of green manure crops, land is prepared by 1 or 2 plowings and seeds are sown when there is sufficient moisture in the field. The recommended seed rate for green manure crops like dhoincha 40 to 45 kg per hectare, sanem again the 40 to 45 kg per hectare, green gram or mung bean 25 to 30 kg per hectare. Sowing time. The seeds of green manure crops are usually sown in the months of May-June, immediately after pre-monsoon showers, more specifically nor'wester in our state, but in some states sowing is done with the onset of monsoon rain in early June. Seeds are generally sown by broadcasting method. As these are leguminous crops, so they require less nutrients, particularly nitrogen, but they respond well to phosphate fertilizers applied as basal. Therefore, 10 to 30 kg P2O5 per hectare is recommended to apply as basal in case of green manuring crops. The best time for turning the green manuring crops in the soil is its pre-flowering stage, that is 6 to 8 weeks after sowing, when the crops are succulent. These plants are chopped in pieces either by sickles or by tractors, and they are incorporated in soil in standing water or sufficient moisture condition for easy and quick decomposition in the field. Green leaf manuring. The green leaves and tender green twigs of many species of shrubs and forest plants are utilized for green leaf manuring. These crops are grown on borders of paddy fields or fallow lands, and their leaves and twigs are collected and those are applied in field for utilizing as green leaf manure. These are usually incorporated in soil at the time of puddling of paddy fields. The common examples of green leaf manuring are Glycida, that is Glycidia sepium, Coronja, that is Pongamia pinnata, etc. Benefits of green manuring. We have already discussed about the examples of green manure crops which are commonly used by the farmers. Among them, Dhuincha and Sanem are very common. Dhuincha, that is Sesbania aquilata or Sesbania rostrata. Here you may know that Sesbania aquilata has only the root nodules, whereas Sesbania rostrata has both root and stem nodules. This Dhuincha is grown either as pre-kharif or kharif crop for green manuring, and the average green matter added to the soil is about 15 to 20 tons per hectare. The average nutrient content on dry wet basis of Dhuincha leaves and twigs is about 0.42%, whereas Sanem, that is Crotalaria jansea, is also grown during pre-kharif or kharif season. It can also add about 15 to 20 tons of green biomass per hectare of land, and the nutrient content is 0.43%. Green gram or mung bean, Vigna radiata. In some areas it is grown not only as a green manure crop but as a summer mung bean, and after harvesting of the crop, the stubbles or stover are incorporated into the soil for green manuring. The average yield of green matter is about 5 to 6 tons per hectare, whereas the nitrogen content is slightly higher, that is about 0.53%. Cowpea, Vigna sinensis, it is also grown as pre-kharif or kharif crop. It can add about 8 to 10 tons per hectare of green biomass, and the average nitrogen content on dry wet basis is 0.48%. Pea, Pisum sativum, it is grown as a rabi crop. The average green matter is 15 to 20 tons per hectare, and the nitrogen content 0.36%. Khesari, Lathyrus sativus, it is grown during rabi season, and it can add 8 to 10 tons per hectare of green matter to the soil. The nitrogen content is 0.57%. There are several advantages of green manuring. Number one, supply of organic matter. It supplies green organic matter to soil, which improves soil structure as well as it promotes aeration, drainage and granulation. Number two, addition of nitrogen. We have earlier discussed that the leguminous plants, there is the association of the nitrogen fixing bacteria, that is Rhizobium species. With this association, either on the roots or on both roots and stems, the green manure plants can add atmospheric nitrogen to the soil through these nodule bacteria. Number three, stimulation of microbial activity. The organic matter added to the soil through green manuring acts as a feed of microorganisms, thereby stimulate their activities in soil. Number four, enhancement of crop yield. With the improvement of organic matter and nitrogen status in soil through green manuring or green leaf manuring, the yield of succeeding crop is increased. So this is all about manures and green manuring of organic farming system.